Good morning, everyone. We will continue with our series of presentations. This one is Elements of Design 2. In this presentation, we will be discussing about the lines followed by points. Okay. So, as we've mentioned, when a point is extended, it becomes a line. This diagram is showing us the same. So, even though it is coming out of a point and it is giving a direction to a point, it has a length, it has a direction, and it has a position in space. We are talking about lines at the moment. Visually, lines are capable of expressing a direction, movement, and growth. A critical element in the formation of any visual constructions. Basically, for drawing or for representing anything, whether it is a product, whether it is a building, or even town planning, you need to use these lines to connect or to communicate. So it can serve to join a link, to support, and to intersect with other visual elements. It describes edges and gives shapes to planes. Basically, they articulate surfaces of plane. Like if you enclose a space with the help of lines going in XYZ direction, you will eventually form a plane. So now for line to be visible, it should have a relative thickness. The thickness also depends on what you want the line to represent and at what distance do you want the line to represent. Now the character of, for instance, you have these lines. This is a thin line, this is thicker, and this is the thickest among the three. So if an object is closer to me, probably it will have this thickness, and if it is farther, this, and farthest, this. So this is also a way to symbolize by using the line weights. Now there's another thing to it, that line has types. So the characteristics of a line, whether it is limp, bold, graceful, it is determined by the perception of its length-width ratio, its contours, and the degree of continuity. So we have shown these two different types of line types. Okay, and they are used for different purposes. Now, if a simple repetition, if it continues enough, it is also considered as a line, but it should have some textual quality. Like these are different textures only. These are boxes which are whether these or these, they are equal. They're equal repetitions. So if this line is really long and it is repeating the same texture, it is also known as linear direction or linearity. It comes under the category. So, and even this, if you have this ABCD, this is written in a line in the same format, in the same texture. So this is also linearity. Okay. This linearity could be horizontal or it could be vertical. Now the orientation of a line affects its role in the visual construction. Now if we consider this as an x-axis or a y-axis, so if it is vertical, then we say it is at a height. Okay, and when the line is in horizontal, we say it is resting or it is stable. So this has a dynamic characteristics and this is stable. So now we saw the vertical and the horizontal meanings to a line. Now this is an oblique. Now if an oblique line falls on a horizontal plane, it is a deviation from the vertical or the horizontal. Okay, so it will bounce back and goes to another. So it can be seen as a vertical line falling on the horizontal and then rising again. Okay, so again it can fall down, it can rise again in different directions. So this is how geometry works, and the lines also works. In either cases, In either cases, it is visually dynamic, active in its unbalanced state. It is unbalanced because it is falling from one point to another. But it is dynamic since it is generating some movement and area of interest for the viewer. Okay, and it is active because it is moving. So let us see the example. This is one of the buildings. Now let us see an imagined element that is the visible one. So the imagined element is the axis, the axial line. We also discussed this in a previous presentation where we said that the point that if there are 2 points, they are vertically extended, so they become a tower, and the relation they establish is that of an axial design. So this is an example of an axial design. So vertical linear elements can define a transparent volume of space, which is outlining a spatial field. So the transparent volume of space is the volume of this cuboid, and this black line is actually the spatial definition to the volume, and these are the axial lines. So if we look at this sketch, which is probably a conceptual sketch of any design, so these are the 2 important points. Okay, and these are the other important points, which is having sub-important parts around on the sides of a axis. So these could be other major parts of a design, but these 2 are the important ones. Now from this, person can deviate to any direction and access any other component in a design. So it is basically reinforcing what we studied in point, and it is reinforcing that the line is also following the same concept. So over here, this image is of Hagia Sophia. So this is arbitrary being taken, and this is trying to say that this is the field which we are talking about, these points which vertically were extended, and then how they are enclosing transparent volume, and this is a spatial definition to it. So I hope this point is clear. We have other examples for the linear elements. These are colonnades, number of repeated columns. These are basically points. Number of repeated columns which have extended and provides shade and shelter to the pedestrian. So these are also linear elements, though they are points, but when they are repeated and they are in enough continuity with texture, so this is a linear element. Same goes with the bridge. A bridge is also a linear element. It is a horizontal linear element which is stable. It is not dynamic. So linear members possessing material strength can perform structural functions, support movement, and provide framework. So this is also a linear element. So these linear elements, they possess a material strength, which means these are made up of different materials. Okay, and they can perform different structural functions. Okay, and they support movement. This also support movement. This also support movement, and this one also. Just that they are at different locations, and they provide a framework. So I hope linearity is clear. Lastly, we can see linearity in plans and then in elevations of a building. So in plan, we see that although architectural space exists in 3 dimensions, it can be linear in form to accommodate the path of movement through a building and link its spaces. So what we saw conceptually is shown in the form of a building. This is your axis, and these are practically your spaces, the functions which you have in a building. And this is in elevation, how a repeated texture and enough length gives it a name for a linear geometry. So thank you. We will now continue with planes in our next presentation, and followed by that we will have a flipped classroom activity in the in-class segment. Thank you.